In this example, we're going to convert the denary value 4367 into hexadecimal. And to do this, remember I've shown you how to use the quotient method. Now the quotient method works something like this. You take the 4367 and you divide that by the base value of hexadecimal, which is 16. So if I do that, how many 16s go into 4,367? Well, the answer is 272, and that's my quotient value. But 16 doesn't exactly go into 4,367 because there's a remainder, and if you work out what the remainder is, you'll find that it is 15. So I'm going to put that over there. Now, that remainder, 15, in hexadecimal, you should know has a value of f. So I'm going to put my f over here like that. Now what I do is I take my quotient value and I'm going to continue dividing that by 16. So 272 divided by 16, well, the answer to that, the quotient, is 17. So I'm going to put 17 there, and there is no remainder. It goes in, 16 goes into 272 exactly. So I'm going to put a 0 in my remainder column here. And over here, what I'm going to do is I'm going to record the fact that I've got a 0 and then an f. Notice that the 0 goes in front of the f value that we had already. So now let's repeat that process. I take my quotient value, which is now 17. I'm going to divide that by 16. How many 16s go into 17? Well, we know the answer is going to be 1, and the remainder is going to be 1. So what I'm going to do with that remainder 1 is put that in front of the hex values I've already got. So I'll end up with 1, 0, and an f. Finally, I'm going to take my quotient value, which is 1, and I'm going to divide it by 16 as I've done before. 1 divided by 16 is going to be 0. It's going to leave me with a remainder of 1. So I'm going to take that remainder of 1 and I'm going to put it in front of the other digits I've got, the hex digits, and I'm going to get 110f. And therefore 4,367 base 10 equals 110f in base 16. Now just remember the fact that in the beginning of the question 4,367 was the denary value that we started with. Let's just check that this works. So we have got 110f base 16. So what would that look like? Remember, hexadecimal comes in groups of 4 bits at a time, so the 1 will be worth 0, 0, 0, 1. The other one is 0, 0, 0, 1. Then we've got 0, 0, 0, 0, and then the f will be worth 1, 1, 1, 1. Okay, if I add those values together, what will I get? Well, I'll have a 1 plus a 2 plus a 4 plus an 8. Now, there's no 16, there's no 32, there's no 64, there's no 128, but there, if I double 128, I get 256, so that's in. There'll be no 512, no 1024, no 2048, but if I double 2048, I'm going to get 4096. Now, if I add all of those values together, hey presto, I get 4367, which is base 10, which is the value that I had at the beginning of the question. So the quotient method does indeed work.